Ladies and gentlemen, Mr. Jonathan Wright is a strategic thought leader and a distinguished technology evangelist. He specializes in emerging technologies, innovation, automation, and has more than 25 years of international commercial experience within global organizations. Mr. Jonathan combines his extensive practical experience and leadership with insights into real-world adaptation of cognitive engineering, generative AI. Yes, we have something really amazing with generative AI that I discussed with Mr. Jonathan now. In his spare time, he is a member of Harvard Business Council AI Alliance for European Commission and chair of the review committee for the ISO IEC 2029-11-9 Part 8 Model-Based Testing and Part 11 for the testing of AI-based systems for the British Computer Society, BSc, and CIGIS. Mr. Jonathan also hosts the QA Lead based in Canada and the author of several award-winning books 2010 and 2022. The latest with Rex Black on AI for testing. Also, alongside, we also do have Mr. Toby Marston with us, ladies and gentlemen, the Global Alliances. So, may I kindly invite Mr. Jonathan Wright as a strategic manager and Toby Marston, the VP Global. Thank you so much for joining us, sir, and over to you. We can't wait to hear your generative AI music now. Yes? They have a surprise.
Exactly. We're going to get, you're going to get generated music that's never been played since about 5.5 minutes ago when we created it. So, we're in the ballroom, so how can we not get ready and get some of this energy going? Of course, I'm joined today by my good friend, Toby Martin. We both started in the industry about 25 years ago, specializing in automation. We're now kind of focusing on bringing to Keysight the next generation of artificial intelligence solutions. So I guess when you joined about 7 years ago, was the first time we started enabling AI for our customers, right?
Yeah. I think, you hear me?
Not quite yet.
Is this on? Hello?
It is on, but very low.
You switched on.
Hello. Hello. There we go.
There we go.
Yeah, so I joined Keysight in 2020 as part of an acquisition they made of an organisation called Eggplant. And we're going to talk to you today about how Eggplant can help you automate the software testing practices around the aerospace and defence industry.
Wonderful. So, the introduction you got earlier on, I was actually at the British Computer Society last week talking about quantum computing. So I've been working with Keysight on the next generation quantums. We actually, the last session we was watching around some of the qubit testing and really the leaps and bounds that this technology is now doing. So actually I was here with you last year talking about the metaverse. I don't know if anyone remembers last year, it's a long time ago, but we were doing some testing on the HoloLens for the Department of Defense, so doing stuff for the military. If you remember, they had a huge contract around being able to build some of these complex systems for the future. But of course, technology, and I guess it'd be easy to say that actually augmented testing as well as AI productivity tools like Copilot have pretty much become mainstream and potentially have made a huge amount of noise in the industry. So this is actually a Keysight-based slide that I presented a few weeks ago at the Google DeepMind in London. And you can probably see some of this information, some of these kind of use cases around quantum at $1 trillion market opportunity. I was actually sat down with our good friends from Infosys who actually valued the generative AI space at about $16 billion, which is a huge market opportunity, as you probably could guess. Of course, we're going into a bit more aerospace and defense today and some of these other complex edge cases. So, what is it? And like I said, we're going to give you some real world examples. There's a photo we took this morning with this gentleman on the front row. And we're now going to show you two of these main types of technology. I guess most people are very familiar with general universal networks, GANs. So you've all probably seen things like DALL-E to generate images or art, work of art. And you're all probably familiar with ChatGPT, right? Everyone here? Everyone use ChatGPT? Great. So we're going to show you some of the technologies, how we generate this stuff. But of course, we couldn't do this without the latest technology. And as you can see here, we've got the hype curve that came out back in August, and I was sat with the Gartner analysts a couple of weeks ago in another event, and part of it is literally generative AI could not be higher. Now, if you go to eggplantsoftware.com, you can download this report completely free. It's about 40 pages, and it goes through every single component that you see here, from prompt engineering to the future of AI engineering and design. So definitely worth checking that out. So, like I said, I promised you a bit of fun. Actually, I didn't get it out of my laptop out because we're presenting through here, but I'm guessing people have heard about this new technology of NPUs, right? Neural processing units. So my laptop, which is in there, now runs 40 trillion operations per second. 40 trillion operations per second. That's the minimum requirement for Copilot to be able to run this kind of technology at the edge. So the stuff that you're seeing today, I've literally generated through my local, in essence, tablet, which is incredible technology. And I'm sure some of you are very familiar with the Snapdragon X Elite as well, as most devices are starting to bring this on board. But anyway, as I promised, we're going to explode the stage and try and give you, and hopefully drag some more people in. And we're going to transform ourselves into eggplants. Everyone know what an eggplant is? Aubergine? Great, we know what an eggplant is, so we're going to transform us like magic, but we're also going to play an exclusive song that Toby's going to sing against. We don't know what it says, but it's going to be huge. Come on, get on. Don't know what it says. What's it mean? Eggplant test. Okay, that's enough of our dancing. Thank you very much. Come on, give me a round of applause. We've got to let on there today. Thank you to a few people from out of the foyer, which is good. You can see that photo also just got dropped onto, I know, copyright might be a slight issue with this slide. So we decided to save ourselves the budget of being able to think of ourselves, what could we call the product? Apple Intelligence? Eggplant Intelligence? Sounds like a good launch plan for me. So we presented this at Forrester a few weeks ago, and they were trying to say to us, what does it really mean? What does Gen AI really mean to the world today? It means your Nokia phone ringtone can be evolved to play any track you want. You're feeling happy, it plays happy. You're feeling sad, it puts on some classical music. But anyway, part of it is, it's understanding these incredibly complex systems. We've all seen that, and we'll demonstrate some of those today. And when it comes to aerospace and defense, it doesn't get any more complex, right? So, over to Toby. Talk us through some of the use cases that we're testing today with Eggplant.
Yeah, so we've been in and helping aerospace and defence clients for many, many years. We're actually part of the standards in the US for defence bills as well, in terms of the architecture support. So where Eggplant excels is across multiple different use cases. Everything you see on this screen we are doing today with either a military organisation, a defence contractor, etc. All the way through from product testing in heads-up displays through to satellite systems, missile systems. But the other thing down here is these business systems. Also automating SAP, CRM tools, etc. to help people to manage the estate of that enterprise IT landscape. So we're helping all of these different organisations produce products, embed software into those products, and test the user experience of those products on the physical devices.
But I think it's more than that. Most of the time that we speak to customers, they're turning around and saying, we've got this submarine, and it's got some nuclear system. How do we test the launch system? And they say, well, we can't tell you what it looks like. Can't tell you how to interact with it. Can't tell you pretty much anything. Everything's ITAR regulated. I mentioned about the HoloLens. You know, I was there in Santa Clara testing this, where they're able to see through tanks, they're able to see the battleground through walls. You know, this technology requires a new type of tool. It requires something that can be ultra fast. It can be running at 120 frames per second for the US Navy's F1 kind of aircraft, which is what the demo I think we've got out in the booth at the moment is testing those kind of military aircraft at high speed. But what are the use cases? Because part of testing it, if you were sat there in the cockpit and you maybe have these heads-up display units, you've got to be able to test it as the person in the cockpit, but you've also got to be able to test all the other systems that's set around it. The entire ecosystem. It's not just these mixed reality devices, it's every single interaction. We've got robotic arms. I think we had a conversation, trying to find our earlier conversation, which is happening tomorrow, talking about testing EV units in India, right? Where we can get a robotic system that's able to interact with that.
Yeah, correct. And I think when you look at military use cases, specifically in the aerospace and defence markets, we all know that Jonathan said those systems are very well protected. You cannot install testing software onto the physical environment. So we do what we call non-invasive testing, where we can actually dial in as a real user would into the system, not installing in the physical product itself. So replicating as a real user would what it is visually seeing in that product. Then obviously on top of it, we joke about the Gen AI market with our customers because we've been here for 10 years. We've already got AI-based algorithms built into our product that's helping us to understand risk and coverage to enable people to understand where the problems may lie in those products or those systems.
Yeah, and that could be anywhere, right? If you look at something like this, I think this is the demo we're doing. One of the I think could have been Boeing, but it could have been Airbus. They literally came to us and said, okay, you know, at the moment when they do simulation training, you know, these lights happen on the different dashboards. When this instrumentation goes to a certain point, this should happen. So cause and effect modeling across so many different components, so many different screens. You know, we've got real-time drone flights here, where we've actually got some great demos where we're actually using a drone powered by this technology to actually be able to go into systems and pretty much navigate that device remotely, test it as if it was interacting in the real world.
And this is really important here as well, because this is a GIS system. So it's graphically very dynamic. Things are moving all the time. Eggplant absolutely can test these systems. All the way through to the cockpits. We test the recent NASA space mission to Mars in the cockpit, actually replicating this physical dashboard and testing how the thing would play out before it even got to the planet. So you've done all the physically hard work in a simulated environment before you actually have to take off and go to Mars.
And that was the rover project, which is quite an interesting one. But I think this brings the idea of complexity in, right? We all know the joke about the fact that the first space shuttles had literally the same compute power as a Casio watch, right? But now this isn't an uncommon kind of diagram, right? Anyone seen these kind of diagrams at the organizations they work? Or even the schematics that look like that? You know, we started looking at, in essence, digital twins. About 5 years ago, we started bringing in some of the technology that Keysight had and how they use digital twins to represent complex systems. And we applied that to the software landscape in the same way Keysight traditionally was testing the hardware.
Yeah, and a lot, if you think about, I mean, some of the tools out in the market, the open source tools, they can actually test a very simple web browser, but they struggle to look at that end-to-end user experience across this entire landscape. This is a huge, complex problem to solve. In Eggplant, we can cross multiple systems and domains and applications in a single test environment. So we can actually replicate this problem as the real user sees it from a workflow perspective, as the real user is using the system at that business process level.
Yeah, and I think we're all kind of familiar with the idea that actually we're testing these systems. I don't want to use the word production, because I think it scares most people, but we're doing it as the wheels are coming on. Literally, it's, you know, pushing it along. This is a new convertible tuk-tuk that's available now, by the way. We've just finished testing this. It managed to flip itself over. But this was on our way over yesterday, right?
That's not a fixed pass testing case, is it? Someone pushing it along by his toe. So that is something you didn't know was going to be in the real world, but that actually happened on the road yesterday. So how do you test for those conditions? How do you understand what real users are going to do with your software? You don't. So you have to have a tool that enables you to show all those different permutations and scenarios and enable you to automate as you can go.
An eggplant can give you the leg up, no pun intended.
Yeah.
So, part of this is we talked about Gen AI. What was our Gen AI, direction? I suppose, I remember sitting down with Satish probably about a year and a half ago, and who's the CEO of Keysight, and he was very focused on how do we enable more AI within the organisation, the Keysight organisation. And part of our commitment is we hired the top AI guy directly from Apple, and we started putting together what internally we refer to as Keysight AI, but in all fairness, it's about enabling and enriching our tools that can leverage this kind of technology. Now, as Toby said, we've got 10 years of experience under our belt, and so I sit and manage our R&D team, which is a global team. I've got quantum physicist guys out in Oxford University. I've got teams in Silicon Valley all working on, what are the use cases for the next generation? And so when we started thinking about this, we started asking our customers, what do they need, right? And take this not only in the example that I'm going to give you, which is in aerospace and defense, but actually take this in all of the tools that you see today. How do we enable Copilot or Test Pilot for every single one of our solutions outside? How do we turn regular users into superheroes? How do we make them 100% more productive by giving them not only domain and industry knowledge, but understanding of all the information available instantaneously? So we started a year and a half ago with this idea of let's automatically generate the code. And actually that's quite easy. I think most of you have probably seen things like Copilot for GitHub. That's a basic capability. But I sat down on a call recently with Sam from OpenAI, and Sam was literally buying every single person up who knows automation in the Valley, because they don't want to create what soup should you buy, or what trip should you go on. They want it to go off and book the trip. They want it to go off and understand what the traffic's like or the weather's like to tell you what you should be packing. They want to be able to pull out your phone and say, what have I got in the fridge? How do I make the next omelette? Got to smash a few eggs, right?
Absolutely. Now, Jonathan and I have been doing this for 30 years, so we know why automation is a good thing to do, right? But the reality is, when you don't automate the software testing lifecycle, you find problems too late in the process. So the whole idea of shifting that testing cycle further towards where you need to look at the planning stages, the build stages of your application lifecycle, helps you to reduce the cost of fixing those problems. It's 100 times more expensive to fix a problem in production than it is at the planning stages of your lifecycle. We're just introducing that cost into the lifecycle by not putting automated testing practices together to solve the problems quicker in the software delivery chain. Now, we commissioned this report with one of the industry analysts, IDC, and this is what it came out to talk about when we were looking at how does the AI, ML kind of use cases help to drive that even better. So we can approach this in a very maturity-based way for you and your company. You don't have to eat everything all in one go. Let's get that level of automation started. Let's start to shift the problem analysis further to the left of the software delivery chain. And then when we start applying these techniques, we can supercharge what we do.
And so, when I did my TED talk it was about 7 years ago actually, I was talking about cognitive engineering. So you can literally go to TED.com, type in cognitive learning or engineering, and it'll come across this. It's about the feedback loop, about understanding how the system works, and using what keeps on being talked about today, the measurement of that, to inform the system that you're actually doing. Now this is an evolutional process. It needs to learn from the systems that you're doing. However, it needs to understand them in the first place. Now most of you will be probably aware of things like ChatGPT and the advancements. And I think part of it isn't because this technology's changing the world. If you look at it, and when I did my TED talk, I talked about Alan Turing's original work in 1950. The increase of AI since 1950 has been completely static. It's not changed apart from the 1980s where there was less investment. So even though it feels like the evolution of these next generation technologies are going to exponentially improve. In actual fact, we're at a point that it's just tipping past outperforming humans at a similar capability. Let's say language for a second, right? So part of it feels like it's intelligent, but in actual fact, it's only doing what I would refer to as natural language understanding, which is the ability for it to actually understand contextual awareness. So what you see here is customer knowledge, right? And we had this session yesterday, and part of it was, if you walk into an organization, so we're going to take aerospace and defense for a second, right? If I go to NASA, right? I know I did a podcast a few weeks ago with a guy from NASA. He's the expert, right? He's worked with NASA for 40 years, right? I know automation as my domain, but I don't know what he knows. So part of it is, how do you create and enable everyone to be a specialist in that particular field? And this is where we've introduced EVA, which is our co-pilot capability, which we've embedded into our technology. Of course, it has our Eddie logo on there because it's the same design that the guy who created the Docker whale for Docker created, but in actual fact, we're using this as our virtual personal assistant. But what they then, whatever genderification you want to use for a particular AI assistant, whatever you ask them, it contextually understands the systems you're testing at that moment in time, what you're trying to achieve, but it also understands the domain you're in. So if you're using a particular specialized equipment, which we were looking at in the last section, you either have to learn everything about that piece of equipment, or EVA can actually help guide you, but not by saying, click this, do that, but by doing actions. So what people won't be very familiar with is there's two things. There's something called a large vision model, which is giving the system eyes to understand what's going on the screens and the systems. But there's also something called a large action model, which is what Sam's working on at OpenAI, which is, how do I create those actions to actually go off and do it, to go and test the system. So part of it is, this is evolving very quickly, but partly what we're trying to do is bring that intelligence, all that learning, that domain expertise, that understanding of customer knowledge, but also knowledge of all the products, and enabling you to be better at test design, right? But, we talked to a customer yesterday about this, right? And I know a lot of people are trying to work on it, but I think partly what they've done is they've seen something like ChatGPT, they've gone off, they've experimented with it, they've seen it hallucinate, they've seen all the challenges associated with it, and now they want to be able to adopt this kind of technology. So,
yeah, and I think the other thing Jonathan mentioned earlier about this problem is every person involved in that delivery of software talks a different language. He said that already. There's no structure across, this has got to look like this has got to look like this has got to look like this, so we can interpret what different teams and people are doing. You're not going to get a product owner being able to code. Their job is to understand the product, the domain, the market, and how those things are going to work. You're not going to get a developer understanding how he's going to put a product out to market. So what we're doing with this as well is helping to translate all of that asset knowledge across those different roles in the software delivery chain to help drive these things. Now obviously what the point of this is to reduce waste, to move things faster, to improve the quality of what we do. And these are the types of statistics that we're seeing in the early projects we're working on about where we can help solve some of these problems and deliver value back to you to eradicate some of these big waste areas in that software delivery chain.
And it's interesting because, like I said, I started back in the early 1990s, and my mentor was a lady called Dorothy Gray, who's referred to as the grandmother of automation. She wrote the first automation script for Bell Labs in 1965. She, myself and her published a book in the early 90s on software test automation, and we put this quite poor algorithm. If anyone's very good at maths, you'll realise it's not quite accurate. But we realised that actually 50% of the time we spend is in the design phase. The time where you're understanding, well, what should I test? How should I test? How do I validate that that's the right thing to test? And so we spend a lot of time, and these tools, or if we talk about tools, we're usually talking about execution, improving, duplication of effort, look at test case optimization, look at reducing manual effort. And I don't think that's the future. It's not about faster horses. It's not about, removing people out of the equation. It's about bringing people back into the equation and then actually enabling them to do more with less.
Yeah. Now this is what we talked about the software delivery chain down here. And our philosophy is quality engineering. Engineer quality into every phase of the delivery process. Quality is everybody's responsibility. It's not just the testing team's responsibility to find problems, it's the designer's responsibility to architect the designs and the processes in the right way that enables the testing to happen to understand the risk. So every phase of this delivery chain, we need to start thinking about how do we drive this. Now we've tried, let's be honest, we've been doing this for 40 years and we've been trying to structure this and standardise this along the way. It's hard, it's not an easy thing to do. What's happened now is we've got the technology to help us to do this faster, better, more robust, in a more robust way. And that's the evolution of Gen AI and where Jonathan's going to take this product in the future.
Exactly. And back to Google DeepMind, part of it is, this isn't my quote as much as I'd like to give credit to it, right? Is we've all heard this one before, right? AI will not replace you, but a person, or the person next to you, using AI will, right? Part of it is, I looked the other day at my bank statement, which is always quite impressive, and the amount of tools that I use, productivity tools, AI productivity tools, like Copilot for Windows, that help me do things better, faster, and stop me wasting time. When I did my TED talk, I talked about let's just ban email, right? Just get rid of email. Because it's the digital grind. We should be able to, which Copilot does, understand what needs to be done, the action that needs to be taken, and take the action, right? We don't need to be sending another email. We don't need to be sat exactly for 60 minutes in every single Teams call. And equally, like a lot of the elements, like Recall from Microsoft. Has anyone seen Recall? Heard about Recall? Microsoft Graph? So these are the new technologies that they're building in. They're replacing Windows Explorer with AI Explorer. That comes into the new version. But Recall understands exactly what you do on a daily basis. And it looks, by doing process mining, it looks at ways of, in essence, automating that for you. And this is large action models. It's just happening already under the hood. And so Recall is going to be game-changing because it's part of, let's not spend time doing things we don't want to do. Let's start doing things that are going to make a difference. And this is the difference about systems, right? We had to teach, I use the word teach because it's not the correct term when it comes to cognitive learning, but we had to, in essence, teach it to become a domain expert in this particular area. So part of it is, if you think about something like equivalence partitioning, or you think about boundary value analysis, they're all blueprints that traditional testers will use. However, what does that actually mean for how you test the complex system? Part of it needs to learn testing. And I joke about the fact it's like Neo in the Matrix learning Kung Fu, right? He says, I know Kung Fu. However, what happens next? He takes on Morpheus, who also knows Kung Fu, knows the exact same amount, so what should happen? They should draw, right? But they don't, and that's because Morpheus has wisdom. He knows how to bend the rules. He's seen those paths happening before, he can predict them. Cognitive engineering and learning will only take us so far. The rest is human augmentation, it's human intelligence, and that's where everyone here needs to become an AI whisperer. You need to be able to understand, to be able to talk to these systems, learn prompt engineering, but more importantly, realize that actually a lot of this is taking away the difficult understanding data and information and actually be able to act on it. And so, what's really interesting is we talk about this kind of knowledge, we talk about creating a subject matter expert, but there's huge regulation coming in. There's a regulatory change which I've been part of, as the intro said. So I sit on the European Commission for the new European AI Act. And what the AI Act is trying to say is these principles here. I'd use the word do no evil, which was Google's mantra, but actually it's not their mantra anymore. Even their chief ethical officer left, is that actually you have to be accountable for building these kind of systems now. You need to understand and be responsible for making decisions with these tools. This is actually for those who are Keysight employees, this is our generative AI guideline that we had to do because there's a new act in the US taken from the President of the United States, which is now enforcing that you have to be able to show that you're doing these things, otherwise they'll stop you from actually being able to trade. So these policies make GDPR and the California data privacy look like, small fines.
Yeah, and I think this is like any other new technology. Right? We saw it in the mobile wave. I was talking to Jonathan yesterday about some of the things we did when I did this about 15 years ago in mobile, that we developed things in isolation in a stack that wasn't in the enterprise IT domain. This is hitting the enterprise IT domain. And as it goes in the enterprise IT domain, as John said, you have to have these standards. You have to adopt things in a certain way. They have to be secure, they have to be driving you. And if you really look at where Gen AI today is, it's probably in that prototyping experimentation phase. Has it been put into our enterprise IT environments? But we can absolutely use this to help supercharge what we do. So we have to start thinking about how we adopt this in an enterprise IT way. The security, the standard, the transparency, the accountability. It's not just, I'm just going to go and use Copilot in my own machine over here. It starts to think, you have to start thinking about where the data's going to go. Who's going to be able to see it? How is this secure if I'm using open source capabilities put into my IT stack? So we have to start thinking about how we're going to adopt this in a much more enterprise scalable security way.
Yeah, I think it's interesting. So, we hit it because we went after aerospace and defence, which is one of our biggest industries, and we also went into highly regulated environments as well. We started to build things into iron banking. We had to take everything what you see today, which I'm going to show you in the next couple of slides, all our solutions completely offline. It does not go to the internet. It's secure, nothing leaves that environment, and it can be regulated and audited using these guidelines. And we learned, not the hard way, but we learned that this quite early on, that we'd have to differentiate the way, because there's so many unknowns on here. You have to improve the transparency and also bring back some of that kind of concern around the trustworthiness of this technology. And I know the introduction at the start mentioned I'd just done a book with the rest of the ISO 29119 committee around building trustworthy systems. At the end, I'm going to put up a QR code which you can download the book completely free, which gives you all the guidance around. It gives you an example of what we was doing with MIT around how you implement this in the real world, but it's also got some of the patterns about and the guidelines of how you start building and using this kind of technology. Anyway, let's see the system. So, minus my font issue, probably I've noticed on this one. So, I was asked by Dan. Dan's our CIO, and Dan pretty much 18 months ago turned up to me and said, I want us to build a Gen AI solution which we can bring into the market for our highly secure environments, hire whoever you need to. So we ended up with a whole stack of Apple engineers and a whole stack of people that we had to go off and, I started hiring quantum physicists, and then someone told me I needed astrophysicists. It was an absolute nightmare. And a lot of it was because taking unstructured data and then turning it into some kind of format of understanding, that NLU that I mentioned earlier, that natural language understanding, is actually hard. And so a lot of what you see today, I use the word no large language models were hurt, but literally a large language model is a tiny component of this solution. I'm going to show you just how complex our system is on the last slides. But this is going to give you a bit of an example. It's only a 2-minute demo. I'm just going to walk over it. But this is the system that we've got today, which we've deployed into our customers, into some of the highly regulated US DoD customers. But we're actually using an example from a real NATO document, though it's been declassified. But we're using a real NATO document in this example, and it'll show you how, in essence, we take that single document. So we start with opening these documents, and people who are used to documents, you realise they're a few hundred pages long. I think I put on here there's 688 requirements in this particular specification, but more importantly, there's different subsystems that this system's talking about. It's not just one system that it's trying to actually understand. It's trying to understand the entire ecosystem of NATO classification tools. So here's one which is we're going to use later on, which is SRS 16, which is about adding Titan for military use of classification of documents, but across, in essence, the Enterprise 3.6 environment. What we see is we've got a document which is the NATO document, which is a PDF document, and we upload a new version so it understands what's changed in the document. So out of that document we said there's 688 requirements. It needs to be able to understand those 688 and in essence be able to map them directly to tests that it needs to generate out of the system. Now what you'll see here, the reason why it's in progress and doing stuff is we needed this to be able to run on traditional hardware. I noticed somebody at the toilet since I just went over, who've got an NVIDIA back. You know, part of it is usually you need specialist AI-based infrastructure to be able to run this kind of compute. The second thing is, I mentioned I was on the ISO 29119 committee. This is every single type of testing pattern, from alpha testing, anomaly testing, to bottom-up testing, boundary value analysis. And it has to understand this. It can't just say, what is boundary value analysis? It actually needs to understand how to actually implement for that customer. It needs to be able to do negative tests, i.e. the guy pushing the tuk-tuk with his leg, as well as the value paths through the system. So it needs to know, like Neo, it needs to know Kung Fu. It needs to be able to understand the complexity of the system. Now, interestingly, if anyone's used Copilot for Office, this is what you've got here. And if I ask it a question like IKN SRS6, has no idea. Even though this is enabled into Excel and it's structured in a format it should be able to understand, it can't understand it because it doesn't understand the contextual relationship between, in essence, a reference, IR SRS6, to what does it actually do. So part of it is, yes, these tools are great to be able to use Microsoft Copilot for Windows and your Office suite, but it needs to understand and be able to process all of the 688 requirements behind you. Now, of course, that takes a bit of time. And partly what you see is once it's created those 688 tests, each one of these needs to generate not only the test which you have to go off and test, the automation script that you want to be able to run, but also the gherkin script that allows you to actually test that in a structured format. So we've got the requirement on the left-hand side, got the gherkin on the right, and then what we're going to see is, okay, it's testing, you know, OneDrive, it's testing, you know, the Office, Microsoft PowerPoint. And so it started creating these test cases. You know, you must verify that you can click on this, or you must be able to change the classification on a documentation. So it's going through, it's generating and recommending the test that you should run, but more importantly, it's telling you how you can actually script it. So we have something called Sense Talk, and as you can see here, it's going through and it's changing it from highly restricted to restricted and then back again. Part of it is it's natural language formatting, but in actual fact, when it comes to testing this using our tool on the left-hand side, which is Eggplant, when it goes into what we call this non-invasive testing, it can drive and test these different components on different platforms. It doesn't care if it's using, in this case, PowerPoint, but if it swapped over like it described in the requirement, it needs to be able to test it as in OneDrive or something else. It can find the same information and then test that as well. So part of it is we test it like a human does, but we're also able to test the actual logic. And what you see is actually there's an error. It's saying that it's got an internal error that it's gone through, and then it picks it up. Now the other thing that I said, and it's a really quick 2-minute demo, but you know, we had to enable Eggy to understand that information. So when you say to it, what's the difference between requirement, you know, IKN 6 and 5, it understands the relationship of that data and it actually can give you a response. Now what's interesting about this is all large language models will tell you where it found the information. The problem is that Sam, which I know, didn't want to tell you where it came from because obviously it would have said where it had been trained on. There's a slight problem. But this will tell you not only where it's from, but what piece of source of information was, and it'll tell you, in this case, it's made it's used its capabilities to understand what the difference is between these two components. The same thing is, if I wanted to ask it about testing, so in this case, what is branch combinational testing, it can understand that. The same thing is it should know that it comes from ISO 29119 Part 4. So part of it is, it gives you the ability to understand how to test, but also it understands the contextual nature of how the system actually works. So very, in essence, complex system, but this is completely all offline, and as you can probably see, it just runs on our in a web interface. Now, finally, I said two things. I know we've only got 2 minutes left, but we got the benefits of using this kind of tool, and we did 2 things. None of this was done by chance. We've had a product that's been around for about 22 years, which is called SenseTalk, which can automate anything. As long as you can see it, you can automate it. It doesn't matter if it's a plane, a heads-up display, a mixed reality headset, it can test it. But more importantly, what we've had for the last 10 years is the model-based testing capability, which is, in essence, testing digital twin systems. And this is where we've used TensorFlow and our algorithms that we've been using for a very long time to be able to tell you which test to run. Once you've got these models, then you can go off and test incredibly complex systems. Now the good news is I realised there was no Q&A, which means you got to see the interesting slides. But I presented this yesterday, I just realised there was the audience, otherwise I would have previously not added this slide in. But part of it is, I don't know if anyone's seen Hitchhiker's Guide to the Galaxy, but Hitchhiker's Guide to the Galaxy, or what they refer to as Babelfish, the Babelfish, in essence, can take any language, code, Hindu, whatever language you want, and then actually convert it to either an action or some automation. Now, what we learned quite quickly is a few things. Is one, English is not the language to use, right? So we've had customers in Japan who use Japanese fine-tuned models which outperform their English counterparts. But secondly, is if you dictate what the output needs to look like, then in essence the transformation that the Babelfish is doing sometimes limits you. So what we've now done is we're starting to generate things in Python, JavaScript, SenseTalk, Gherkin, markup language, and we can run all of that in the same flow. So you're not having to say, oh, I'm limited by one type of technology. Anyway, finally, with my 20 odd seconds to go, this is what we built, and I'm going to hope that this moves me forward slightly, is we built, in essence, a large language model router, which is a poly AI, as they would call it in the industry, which in essence allows us to choose 2 models that run simultaneously. One that could be language, one could be code. It detects whether it is code or if it's Gherkin or if it's Python. It corrects the correct model. It then uses that Babelfish universal translator to translate it and then actually use either computer vision, which is what we've had for a long time, cognitive vision, which is in essence YOLO. It's the stuff what you're seeing on the bottom right, which is Microsoft's technology. This is OpenLAM, Open Large Action Model, in the bottom right corner. And what you'll see, or not see, is over here, it's understanding the contextual awareness of what's going on. And this is called real-world open-ended problems. If you wanted to, say, play a track like Taylor Swift, or I was at Robbie Williams 2 days ago, and you didn't have Spotify, it would realise that you haven't got Spotify installed, it would go and play it on YouTube. If you haven't got a browser or internet connectivity, it would go and look in Apple. So it would choose based on what it's seeing, what the visualization thought is, what its eyes are doing. So part of it is we've created, just to make things final off while the time is up, is we've created a neurosymbolic model, which is a new type of languaging which is being developed within the industry to be able to actually be intelligent AI agents that can go off and test these systems independently, but also can deal with open-ended real-world tasks. So anyway, nice and simple, a few minutes over schedule, and like we promised, there'd be one more track to finish us all off, which I'm actually going to invite these guys at the front to come up. No, it's these. Come on, Krishna. So, yeah, this is the song for this is the free book. Back
if you want to see eggplant in action, we've actually got it on one of the booths over in the other side of the hall. So if you want to go and talk to one of our technical experts, you can see it working over there for you as well.
Good call to action.
Thank you.
Thank you very much.
Thanks everyone.
Thank you, Larry.
Oh my god, that was so energizing, trust me. I think I wasn't needed on the stage though. Alright, ladies and gentlemen, that was taught by Mr. Jonathan and Mr. Todd.